Let us discuss a question from strength of materials. This is from torsion of shafts. So basically a three shaft system is given. They are connected in one by one at the end, so basically in series you can say. And then you have what is asked is the torque loading is applied at two ends. So this is 4 kilonewton per meter. In case if it is not, I am just writing out. And so what is applied, what is asked is the angle of rotation at this end. Because of the twist, how much is this theta? So what we do is we just write this end as A, this is B, this is C, and this is T. So there are three different materials. So what is asked is the angle of twist D with respect to A is asked. So that is nothing but D with respect to C plus C with respect to B plus B with respect to A. Now this is, now how do you have, so now if you have a single shaft and you have a torque T, so what is theta? We use the torsion equation. T by J is G theta by L, and therefore the theta is nothing but TL by GJ. So G is again the shear modulus, rigidity modulus basically, and J is depending on the cross section is pi, circular cross section, so pi by 32 d power 4. It's a polar area moment of inertia. So pi by 32 d power 4. So now we'll use this. Now DC is nothing but your bronze shaft. So for the end DC we'll just use what is the torque that is acting on the bronze. Throughout this is one cross section bronze and the torque is 1.5 kilometers. So we'll use this formula. So I'll just use this directly, TL by GJ. So okay, so the torque, okay, so let's write down this. So 1.5 kilonewtons, so 1500 Newton meter is the torque. Length is, so everything I substitute in meters, remember. The length is given as 1.5 by G, which is the shear modulus of the bronze, that is given as 35 GPa, so 10 power 9 because in Newton per meter square, and J is pi by 32. You can calculate J before and substitute the final value, but I am substituting the direct value. So pi by d power 4 d 75 mm, so 0.075 whole power 4. This is for the bronze. Now same thing we apply for CB. CB is nothing but steel, so it's 83. So now torque is again when you come from the right and you take a section anywhere in the bronze, the torque is, resistive torque is 1.5. When you come here, the resistive torque is again 1.5. So steel is also 1.5. So that is 1500. Length is 2 meters by G is 83 GPa, so 83 into 10 power 9 into pi by 32 d power 4, which is again 75, so 0.075 whole power 4. This is for the steel. Now plus, now we'll have for the aluminum. Now aluminum, what is, if you take a section here, what is the total torque towards the right? So 4 is clockwise, 1.5 is clockwise, so it is 5.5 clockwise. So at this section the resistive torque is 5.5 clockwise, so it's 5500 in Newton per meter. So that is the total torque into length is 3 by okay, the GPa is, let's say how much, that is 28. Okay, 28 into 10 power 9 and into it's 100, so it is 0.1 whole power 4 pi d power 4 by 64. So now this entire value you should multiply, because this will come in radians. So in order to get, you have to multiply by 180 by pi. So this will give in degrees, and this is 5.29 degrees roughly. Okay, so 5.3 degrees you can say. Okay, so this is a simple problem, only you should know how to apply each of the term. So 5.3 degrees. Thank you. This is the angle of twist at the free end. Okay, assuming that the left end is fixed because it's theta d with respect to a, and a if you assume it is fixed, so this is theta d. Thank you.